Question 2 of part A. Given is the sequence un equals 36 divided by n squared plus 2 with n is greater than or equal to 1. Things to notice right away that this sequence is given to you explicitly, and that n is greater than or equal to 1. So the first term is going to be n sub 1, not n sub 0. Looking at that explicit form of that sequence, notice it should be obvious that as n increases, since n is only in the denominator of the first part, as n increases, the part 36 divided by n squared will be getting smaller and smaller and smaller and smaller. Eventually, as n increases indefinitely, if n became really, really large number, the first part would be very, very, very close to 0. And so this, looking at it, or this type of thinking of what the un is going to be as n increases, will give you some insights as to, for example, what the limit of such sequence could be if you're asked that question. But first, here we're asked to just calculate the first 3 terms of the sequence. So notice part A is worth only 1 mark for writing the first 3 terms of the sequence. I would even write that n, this is the part where n equals 1. The next term, it will be when n equals 2, and n3 will give us the third term. So u sub 1 is 36 divided by 1 squared plus 2. u2 will be 36 divided by 2 squared, so 36 divided by 4 plus 2. And the third one is going to be 36 divided by 3 squared plus 2. So the first one is going to be 38, the second one will be 11, and the third one will be 6. So these are the first 3 terms of the sequence. Show that the sequence is strictly monotone decreasing. So we're somehow to show that the sequence is only doing the same one thing, and that it's going down, down, down. And you can kind of see it from the first 3 terms, but we're basically to show that this is the case. When we are given the sequence explicitly, the best way to go about showing this type of behavior is by considering the slope of that function, or the derivative. If we can show that the derivative is less than 0, that is always less than 0, then that associated function is always decreasing, meaning the sequence will be decreasing. And monotone. Monotone just means that it's continuously decreasing all the time. It never stops decreasing, it never goes up. It's doing the same thing. Monotone just means doing the same thing, basically. So I would just take the derivative with respect to n. Our variable is n. So let me write it like this, because I don't want to use the quotient rule. So I'll just put the n into the numerator. So I'm not taking the derivative yet. I'm going to use this type of notation. So we're taking the derivative of that statement there. So negative 2 times 36 is negative 72, and to the negative third, and the derivative of 2 is 0. So basically we have negative 72 divided by n cubed. And since n is always a positive number, n cubed will be a positive number, and we have a negative value in the numerator, so we can say that this right here is less than 0 for all n, which basically is enough to then conclude. So that means un is monotone decreasing for all n, which is what we wanted to show. Um, okay, in part C, we're asked to find the value to which the sequence converges. To converge means to come to a certain value, to come to a certain number. Maybe this question was worded vaguely, or maybe some of you did not understand what this question wants from you. But when we are looking whether a function converges, we're basically considering what would be the limit of this function as n approaches infinity, unless we're told what the limit or what the sequence approaches as the n approaches a specific number. If it doesn't say a specific number, we need to consider plus or minus infinity. In this case, n is only and are positive values. Some of you may recognize the form of that function or what its graph would kind of look like. But to earn the 2 marks that are possible here, to earn those 2 marks, one of the marks was for writing, I guess, that we're looking for the limit of un as n approaches infinity. And then remember to continually write the limit until you are actually evaluating it at the end. So this is the limit of 36 over n squared plus 2. You could skip here to the very end and just write the conclusion. I will break it down here. Again, making sure that my train of thought is visible on the paper. So the limit of that first part, of course, as n approaches infinity, will be 0. Limit of 2 will be just 2, and so the limit is 2. And again, you should kind of see this just by looking at that function itself. So as n approaches infinity, the first part disappears because it's approaching 0, leaving us only with the 2. Again, make sure that your final answers are visible, that you explicitly answer every question. Don't leave any doubts to what you found as the solution or as the answer to the question that you're being asked.